Let's take a look at what scatter plots can tell us. Once we create the graph, we can gain a great deal of information about the relationship between variables just based on these plots or graphs. We're going to talk about direction and magnitude or strength of the relationship. The first thing we will look at is the direction. We classify linear correlations three different ways: as having a positive or direct relationship. Both words are used interchangeably. This means that both variables move in the same direction. For example, as the amount of time you spend working on your statistics projects increases, so does your grades. When looking at a scatter plot, we'll notice the pattern moving up from left to right. Negative or indirect relationship, again, the terms are used interchangeably, means that the variables move in opposite directions. For example, as the temperature outside goes up, my heating bill goes down. When we look at a graph, we'll notice that the pattern trends down when read from left to right. No linear correlation creates a graph with no apparent pattern. We cannot visualize a linear pattern. Let's take a look at what this graph is showing us. This graph is a linear correlation, and we notice as we look at the pattern going from left to right that this is trending upwards. We see these dots start to rise. If you were to draw a line approximately in the center, we see an upward trend. This is a positive or direct relationship. Let's take a look at another graph. This one already has the line of best fit drawn into it, but you can see as we look again, and it is important to read from left to right, that this is trending downward. The line of best fit or regression line is pointing down. This is a negative or indirect relationship. Looking at this graph, we notice that there is no apparent pattern. Actually, a line of best fit drawn in here does have a slight positive trend, but it is almost horizontal. You don't really know where that line would go. There's no clear indication as to whether it's going up or down. This has no linear relationship. The next thing we'll look at is the strength of the correlation. The more linear the pattern is, or the stronger the data points cluster around the line, the stronger the correlation. We'll classify these as strong, moderate, or weak. This is open to a little bit of interpretation. It's not quite as clear as the positive, negative, but we can get a general sense as to whether there's a strong relationship, a moderate, or a very weak one. The first examples of graphs we have show a perfect linear relationship, positive on the left and a negative on the right. This is actually very rare in the real world, but it does give you an idea of what a perfect relationship looks like. All those dots fall exactly on the line. When we look at a graph, we start to look in the real world, which is very rarely perfect, we start to look at how strongly the graph clusters. These are a pretty good graph, pretty nice line. We do have a few data points straying, but it is a fairly strong linear correlation. You can see a very clear linear pattern trending upwards. Strong positive or strong direct correlation. In this graph, we start to see a lot more variation from the line. Yes, there is a graph or a relationship trending up, but it's not very linear. They aren't very tightly packed into a line. This would be a very moderate relationship. We notice the trend going up, but it's not very, very tightly packed around that line. And then we have this relationship. Without the line of best fit drawn in there, it's very difficult to actually see the linear pattern. There is a slight linear pattern, but it is not that impressive in terms of forming a very tight line. This would be a pretty weak correlation. Again, this is open to a little bit of interpretation. The direction is easier to tell from the graph. The strength is a little bit argumentative. People will argue one way or another. So we'll look at a different way to also assess strength of the relationship.